Hello, I am JAGANMOHAN, Assistant Professor, Marri Laxman Reddy Institute of Technology and Management, Hyderabad. Today we are discussing about computer system architecture in digital computers and block diagram of digital computers and logic gates. The topics is digital computer, block diagram of digital computer, logic gates and basic logic gates. What is digital computer? Digital computer is a digital system that performs various computational tasks. The term in digital means information is representing using digits. It is nothing but digital means we are using some of the numbers and some of the codes. It will be the data will be processed through with the numbers and digits. So this is called a digital system. Digital computers use the binary number system consisting of zeros and ones. Digital system is nothing but the code will be transferred through the system. Whatever we are giving the input, that will be considered as a zeros and ones in the binary information. The code will be transferred through the input and transferred through the signals through the CPU and will get the output. This is called the instruction. If it is the one instruction completed means whatever the input we are giving to the system, that will be generated through zeros and ones binary information through the CPU and we'll get the output. These process will be called as a whatever the giving we are input and the message is transferred through the registers. Whatever the temporary registers will transfer the information through the CPU and will get the output. The binary digit is called bit. The binary digit is nothing but bit means bit contains information, like a bit contains bytes, 2 bytes. Bytes contains flags. In flags, the information will be stored. The register through the register contains bits, bits contains bytes, bytes contains flags. The information flow through the bytes and in bits registered through bytes and registered through the information will be processed and we are getting the output. And by using code techniques, bits can represented as like we are having some three types like numbers, alphabets and symbols. The bits bytes can be divided, like the code will be divided as three parts like numbers and alphabets and symbols. Bits are grouped as a bytes and words for internal representation. The information will be stored as a like zeros and ones, like codes. These content will be transferred to the CPU, and we are getting the output. A program is a sequence of instructions given to the computer. Whatever the program we are doing the programs in like Java programs or C programs, we are giving the some set of instructions to the CPU. Like we are entering the data through the keyboard or mouse. We are processing the like some of the binary information like zeros and ones code we are giving to the system, and the system will be processed through with the CPU. See, in CPU, the communication between registers, bits and bytes, we are getting the exact output. This will be processed through the CPU and we are getting the output. At the block diagram of digital computer, the main parts of digital computer is the hardware of digital computer is divided into three major parts, that is central processing unit CPU and main memory unit and input output unit. The central processing unit contains arithmetic logic unit ALU. It performs arithmetic and logic operations. Arithmetic logic operations means it is nothing but like the system can perform various operations like addition, multiplication, and shift to right, shift to left. These are called arithmetic and logical operations. The registers store temporary and data instructions. The majorly that registers can perform various operations through the memory, or registers can transfer the memory, like it will transfer the bits and bytes the in bits and bytes also we are the temporary storage the memory will transfer to the CPU and we are getting the output. The instruction will be executed. Finally we are getting the output, and the control unit controls the fetching and execution of instruction. The majorly control unit can do the which operation can do the first, the which operation can do the second. The operations can execute serially, like we are doing multitask in the system. Suppose the first operation will do execute the first, second operation will say execute the second. Like if it is doing through the system, we are doing multitasking means whatever the operations we are giving first, that will be executed for the first and second, third, like that. And block diagram of digital computer, also central processing unit, and we are having some of the diagram of control unit and total system computer architecture. The majorly here we are seeing here like input unit. This is the input unit and this is the output unit. Whatever the input units we are having, like mouse, keyboard and microphone, it is we are giving the instructions through the input, that will be transferred to the main memory first and secondary memory. After that it will goes through the internal memory, arithmetic logic unit and control unit also. And in control unit will decide the whatever the operation they can do. Like whatever the first operation, first instruction will first and last instruction will execute last. And control unit analyze the system, like whatever the operations will be transferred to the ALU or internal memory. If it is if it is we are giving the addition multiplication operation, the operations will be executed here only, like arithmetic logic unit only. Arithmetic logic unit perform various operations, like they'll do the like addition operations, binary operations, they'll execute to the output. After control unit decide the which operation ALU can execute. It will decide the control unit will decide the which operation will be execute or not. And after that we'll getting a output here only, like data. Here we are seeing here monitor, printer, speakers. It is the overview of components of computer we are seeing here. And next is the logic gates. Logic gates is nothing but the binary information is represented using electrical signals. The binary information is nothing but like zeros and ones. Code information will be, we are representing some of the digital logic gates. We are using some symbols. We'll see the symbols also. And signals are represented two states, like high voltage and low voltage. And logic gates are electronic circuits used to manipulate binary information. It is like electronic circuits. We are using some of the electronic units for the binary information, used to manipulate the binary information. Gates to produce output 1 or 0 based input logic. Whatever we are giving the we are giving the zeros and ones, we are getting the output also ones and zeros only. And input and output relationship is represented by truth table. And by the code we are representing some of the truth tables. We can see that. And the types of logic gates, the majorly the types of logic gates as divided it like AND or NOT. And majorly universal gates is NAND, NOR, and exclusive gates is XOR, XNOR. We'll see the time truth tables also, and digital logic symbols also. Basic logic gates. And AND gate is output only 1 when all inputs are 1. Here we are taking like A and B. Here we have to majorly observe that if any input is 0, output is 0, that can be 0. All inputs are 1 means it will come through 1. Here we have to see that A and B are 1 1. The output also 1. Remaining all are 0. So the logic gate and logic gate is divided like this. Like A gate, A and B, and the both are combined through these are A dot B can be represented as and can be represented as and symbol. This is called AND. The majorly we have to observe that it will A and B inputs are totally one, means we'll get the we are get the one. Remaining stages 0 0 is 0 0 1 is also 0 1 0 also 0. A and B will be 1 is when 1 means we are get the 1. So that's output is 1 only, means all the inputs are 1. When we are getting outputs are totally A and 1 B and 1, means the input are 1. And the next gate we'll see. And OR gate is when output is 1 if any input is 1. Any one output means we are getting 1. Like in A output 1, B output 1, we are getting 1. And A output 1, B output 0 also we are getting 1. And A output 0, B output 1 also we are getting 1. The main in, if A also A should be 1, minimum should be 1, or B also should be 1 also we are getting input. The major difference we have to observe here. Here A and B totally zeros, we are getting zeros only. Remaining all stages we are getting single ones in the outputs. A one put is 1 and B one put is also. So that's why here we are getting input is 1. OR gate should be represented as like this. R is nothing but A plus B operation, like addition operation, we can say that. And not gate means in the name only, the not represented as a negative. Like if it is A1, we have to reverse with that. Here also called inverter, and he has one input and one output. Only one input and one output. The output is the complete of input. The truth table is, if it is A0 it will be 1, A1 it will be 0. The symbol is represented here. Only one connection will be there, only one output will be there. And universal gate is NOR gate. The complement of OR gate. Like complement means it is a reverse of OR gate. Output is only when all inputs are 0. Here we can see the truth table. Output is 1 only when all inputs are 0. When it is totally A output and B output is 0, means it will become 1. Here we have to observe that 0. A should be 0, B should be 0, and the output input is come 1. Remaining all states are 0 1 1 0 0 1 1 0 1 1. So that will be 0. The gate can be represented as this, like A to B and output. And NAND gate, AND gate followed by NOT gate. Output is only when output is 0 only when all inputs are 1. When all inputs are 1, it will become 0. Here we have to observe that A should be 1, B should be 1, the input also 0. When A input is 0, B input is 0, the when A output and B output will be 1, the input is 0. The major difference we have to observe here only. When two ones is there, the input will be 0. The gate will be represented here, and the remaining all stages we have to observe that 1 0 will be there, 1 will be there. So all should be 1. And NAND and an OR gate called universal gates, because all other gates can be constructed using them. And exclusive gates, XOR gate. Output is when inputs is different. Output should be 1 when all should be different. Should be A should be like 0, or B should be 1, means it will become 1. Otherwise any output should be one of the digit or one of the 0, it will become 1. Here we have to mainly observe these. 0 1 should be 1 and 1 0 should be 1. Remaining all stages we are getting zeros, like 2 zeros also 0, 2 ones also 0. When two outputs should be different, then it will become 1. The gate will be represented as here. And XNOR gate, output is 1 when inputs are same. When should be outputs are same, it will become 1. See here, the A should be 0 and B should be 0. The input came 1, and last we can observe this, and A1 B1 should be 1. So remaining stages are zeros. The gate will be represented as here. The XNOR gate will be represented as here. These are my topic. Thank you very much.